Welcome back. This is an Aleks training video on setting up a reaction table. A reaction table is a very useful thing when a problem gets very complicated. It's a way to organize your thinking to where you can see exactly what you have and what you're asked to have. So it's almost like a plan, setting up a plan for a math problem. I never did it. I never set up plans for math problems. I just tackled it and ended up going down wrong roads. Organized thinkers would plan what they're going to do, and then they were able to do it much better than me. This is how you do it in chemistry, especially for complicated problems. And it deals with concentrations changing over time. So if you have initial concentrations and then you know what's changing about them, at equilibrium you'll know what is different. Okay? So let's first of all find out what the molarities are of each of these guys. So to the right, I've written the moles that you were given and divided by the liters. So 500 milliliters is half a liter. So it's going to be 0.4 divided by 0.5, 0.20 divided by 0.5, 0.9 divided by 0.5, and the initial molarities. Now, you were not given any initial molarities of the H2S, so it has to be 0. So I'm just going to put this here. So this first one is going to be so that's your initial molarities. The change is based upon what you're looking at first. So usually the reactants are negative. They go away and the products show up. And they're related to each other through the balanced equation through the coefficients. So you can say, so look up here a second. So 1 mole of methane will yield or will require 2 moles of hydrogen or dihydrogen sulfide to give you 1 mole of CS2 and 4 moles of H2. So this, if X is here, then first of all, it's showing you that this side is going to be positive and this side will be negative. So this guy will be negative, this guy will be negative, okay, on this particular table. If the change in X is here and these guys go away, then the ones on the product side must be the opposite side, the sign. Okay, so whatever sign X is established as, in this case it's the methane, if it's X, then and it's a reactant, then the product has to be negative. Also, you're going to have to multiply based upon whatever the coefficient is of what you're given. So I was given one that has a 1, okay, but it really doesn't matter what I have. I'm looking at each relationship separately. 1 is to 2, okay, so that means that this is going to be twice as much, and so it's going to be 2x. This is 1 to 1, okay, so I don't need a number. 1 is to 1, okay, 1 is to 1 of the methane and the CS2. That means that this is going to be negative x. And then the last one is 1 is to 4. Okay, 1 is to 4, so that would be negative, and it has to be negative 4x. Now here's where it'll trick you. Let's look just for a second before we go back. Just maybe it'll help. Let's say x was put here. Okay, let's say x was put here. Then what do I put here? 2 is to 1 as 1x is to half x. Do you see? 2 is to 1 as 2x, or 2 is to 1 as x is to negative half x, because if this is positive, this has to be negative. 2 is to 4 as x is to negative 2x. All right, so you're just going to have to look at whatever you're given and then whatever you're considering, and then all the rest is adjusted to it. The last part's as simple as it can be. All you're going to do is add those two up, So you're going to have, you're going to add them. So you're going to say 0.80 plus x. Okay, this is 0 plus 2x. This is 0.40 minus x. And this is 1.8 minus 4x. Again, this is not an end to itself. This is something that you would do in order to find something else. But it is useful, so it's not a bad idea to learn how to do this.